Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to explore a very important framework, and that is AWS Serverless Data Lake framework. In short it is called as SDLF. Okay, first we are going to explore what it is, what are the core AWS services used in this framework, what are the advantages, which companies are using this to solve complex business problems. On this we are going to explore in detail in this particular discussion. Okay, so before going ahead with actual framework, let us try to recall what is data lake. So as we know, it is nothing but a centralized repo designed to store, process and secure large number of structured, semi-structured, unstructured data, right? Maybe from your vendor company using AWS transfer family, that is using SFTP, some files are coming that can be structured data in CSV, TSV format, or that can be image, JSON, this kind of semi-structured or unstructured data also possible. Maybe from some on-premise system using Scoop, Talent or PySpark, using different ingestion frameworks, the data is coming in our centralized repository. That particular location where all these various format of data, various kind of data is getting accumulated, that centralized repo is nothing but data lake, right? And whenever framework what we use, that time one particular thing directly get attached with that system, and that is reusability, right? That particular system should be reusable, then only we can call that as a framework. So now let us try to explore how using different AWS serverless services we can create some reusable framework for our data lake system. Okay, so whenever any organization need to implement data lake for solving any big data related use case or OLAP related use case, that time they generally get two options. Either they can build that particular data lake system from scratch within their organization, or maybe from some third-party vendor company, they can buy or purchase some data lake framework which is following industry standard. These are general conventional two approaches which most of the organizations follow. But we are having a third option, and that is popular open source project. That is, some developer or some organization might have created a very well architected system and they have published for free to use for different other organizations or individual users. And that is nothing but falling under open source project. So this particular serverless data lake framework is one such open source project which provides a data platform that accelerates the delivery of enterprise data lake. Okay, that is, using this particular open source project, we can quickly build a data lake system within our organization. And this particular open source project is used by large organizations like Formula One Motorsports. It is very popular for racing, right? We all know. And then apart from that, Amazon Retail Ireland also use that. Naranja Finance from Argentina. These are some popular big organizations who are following this SDLF framework to implement data lake in their organization, right? Now let us try to understand, to implement this data lake framework, what are the core AWS services used? Okay, so because this framework is serverless, whatever AWS services we are using to implement this framework, they are also obviously serverless. Like for example, if you consider storage system, we are having AWS S3, which is having unlimited storage capacity. We no need to think about servers and backends. AWS has taken care of all those things on our behalf. And apart from that, if we need to catalog that data, that time DynamoDB can also help us, right? Now, this is for storage. Now we need some compute system for our OLAP, and that time AWS Lambda and Glue can help us. Using Lambda, we can process our data whenever there is light transformation, which can be completed within 15 minutes. And if there is some heavy ETL workloads, that time we can use Glue, which is again a serverless services. And also we need some orchestration tool, like very popular orchestration tool are AutoSys or Airflow. Now because this is serverless system we are going to build, so for orchestration purpose we can use AWS Tech, which is nothing but a serverless service provided by AWS for orchestration, right? So these are the major services we are using in this particular serverless data lake framework or SDLF. Now we will directly jump into the architecture part. So let me just zoom this particular part a little bit. So here in this SDLF architecture, we are having two stages, stage A, and here in the lower part, we are having stage B. First, we will try to explore this stage A, what it is doing there. Okay. So from some vendor organization or from on-prem system, we are getting raw data. Okay. So this is our raw file. that raw file is getting ingested in S3 raw location. So as we know, in our data lake system, we are having multiple layers. The first layer is called as raw or landing layer. Then we are having staging layer. Then after that, we are having processed or analytical layer, right? So let me just give a quick recap on that, and then we will go back to this architecture. So here I have just written some important difference between different layers, what we generally encountered in our data lake system. That is, first is raw or landing layer, and this layer basically contains the ingested data that has not been transformed. Okay, that is exactly in raw format from the source system, it get landed in a particular S3 location that is called as raw layer. Okay, now from that raw layer, we consume the data and we apply very light transformation. Maybe for example, data type check or data duplicate removal. This kind of light transformation we apply and then we store in staging layer. And once data is available in staging layer, we read that data and we apply heavy transformation in it. Maybe for example, joining the data from various sources, performing different filters or aggregation based on the business requirement. And after doing all this heavy processing or heavy transformation, we write the data in processed zone. Okay, so these are the three major layers which we generally encounter in a data lake system. So the same we are going to observe in our this framework also. So I just thought to give you a quick recap. Now we will go back to the architecture. Okay, so here from the on-prem system or from some vendor company, somehow using some ingestion framework, the data is getting landed in raw layer, that is in raw format it is available. Now what happens, as soon as the data get landed in S3, we send an event notification to AWS SQS. Okay, and from that AWS SQS, we trigger one Lambda function. And that Lambda function send that particular event to another SQS queue. And this SQS queue is team-wise separated. Okay, maybe for example, team A, we are having one SQS queue. For team B, we are having some other SQS queue. For team C, we are having some other SQS queue. So this Lambda, based on where the S3 file is getting landed or maybe based on the file name, forward that particular SQS event in one of these SQS queue which are created team-wise. Maybe if that particular message is for team A, then it will send to this SQS queue. If it is for team B, it will send to this SQS. If it is for another team, it will send to this SQS. So like that, this particular SQS queue are created team-wise. Okay, I hope you got this point. Now let me just erase this particular part. So the Lambda has sent that particular event to SQS. Now this particular SQS is team specific. Now let us try to understand within a team what kind of data flow happens with those events. Okay, so till now this SQS queue contains that particular file information what got landed in our raw layer. Okay, it is not yet processed. This Lambda has not processed that particular event. It just acted as a router in different SQS queue. Now this SQS queue has that information that in this particular S3 raw layer, that particular file got landed. And based on this SQS, this Lambda get triggered. Basically, this Lambda continuously poll with some certain time interval that any new message got published in this SQS or not. And once the Lambda get the message, it start one AWS step function. Okay. And here our first layer of processing starts. Okay. What happens that here our step function is getting started. The first Lambda function update the metadata information about our job in DynamoDB. Maybe for audit or recon purpose. That is pre-update comprehensive catalog. Maybe this particular file it started processing. This is the timestamp it started and some other metadata information for future reference for audit purpose or logging purpose. It captured in DynamoDB. Okay. And then it execute light transformation. As I told you that from raw layer, we consume the data and then we apply light transformation, for example, data type check or data duplicacy removal, etc. And then we store in staging layer. So this particular Lambda does that activity, that light transformation. And because this is light transformation, so obviously we can expect that it get completed within 15 minutes. For that reason, Lambda can be a good choice in this particular stage and it write that data in another S3 location. Now what is this S3 location? This particular S3 location is nothing but staging layer, right? From raw layer, we consume the data and then writing in staging layer after applying simple transformation or light transformation, right? And once this particular Lambda apply that light transformation, once this get executed successfully, this Lambda is taking that responsibility to update in the DynamoDB table that this job is completed, this is the end time of that job and all other metadata information, right? So this is a typical AWS step function workflow. Okay, right? Now let's see what happens next. Once the data available in staging layer, this particular event goes to another SQS queue. So here if you see, this particular line is going and it is going like this way, and here that same staging location is there, and here whenever a file get written by the Lambda from that step function, from the staging layer one event get emitted, and that basically write that event in another SQS queue. So this is another SQS queue. Okay, we have encountered multiple SQS queue till now in this architecture. Initially we were having a generic SQS queue, then we are having first team specific SQS queue, then after this processing, here when the staging data is written, then that event is also updated in this particular SQS queue. Now here we are having another Lambda. Now this Lambda get triggered by this particular CloudWatch rule. As we know that using Amazon Event Bridge, we can schedule a particular Lambda or glue job with some certain time interval. So here this particular CloudWatch rule get triggered every 5 minutes, and this Lambda basically run every 5 minutes. What it does, it check in this particular SQS queue any event arrived or not, and when in this SQS queue event will arrive, when in the staging location some data will be written. Okay, and if Lambda find out that in staging location data is written, that means if in this SQS queue messages are available, that time this Lambda will start another step function workflow. Okay, and now we are going from staging to processed or analytical zone. That means this time we need to apply heavy transformation, not light transformation. We might need to apply joins with various data sources, filters we might need to apply, aggregations we have to do based on business requirement, right? So these are heavy transformation on our big data. So that time there is a high chance that it will take more than 15 minutes. So this time we cannot take risk to run our job in Lambda, but rather we should run the job in Glue. So this particular step is doing that heavy transformation. If you see here, start button we are doing, and then here this Lambda is triggering a glue job with all these SQS events, that these are the files got landed in staging layer, that the glue job should read using PySpark or Spark with Scala, etc., and then process it out. Okay, and once the glue job process the data, where it will write? It will obviously write in post stage zone, or we call this processed area or analytical area. This is the final layer of our data lake, right? And once the Lambda trigger our glue job may take 30 minutes or 1 hour, 2 hour, etc. So the Lambda will not wait. It will just invoke this glue job, and then it will send that particular job ID to another Lambda. And here we are having a wait clock, and this Lambda will continuously poll with some certain interval, maybe every 15 seconds or every 20 seconds, every 2 minutes, etc. It will check whether the glue job is completed or not based on the job ID. And if the job is finished, it will go to the next block. And if the job is not finished, then it will again wait for a few more minutes based on the configured value, and then again it will poll for the glue job status. Okay, right? That's how it works. We have already discussed this particular pattern also. Now, once our glue job finishes, what will happen? In the analytical layer or in the processed layer, the curated data is written. Now, analytical team, the data analyst team, need to query that data. How they can query the data from S3? Obviously, one of the best ways is Athena. So for that, they will first run a glue crawler. The crawler will update the catalog table, and using that catalog data, the data analyst team or data scientist team can easily query in Athena. And whenever this particular whole job is running, that is Lambda is triggering glue, processing, this complete information again following that same pattern will be tracked in DynamoDB for audit or login purpose. Okay. So whenever this particular Lambda will submit that glue job, it will make an entry in DynamoDB that this particular glue job started with this job ID. And once this whole step is finished, here you can see this Lambda layer post update comprehensive catalog it is doing. That means it will update in glue that this job is completed and all this information. Okay. And once our crawler is also ready, the audit or recon is also completed using DynamoDB, the last step is data quality check. Because with bad data, business might take wrong decision and it might lead to company's loss. So always we need to make sure that the data, whatever we have generated using our ETL pipeline, is having good quality. So that time we can implement another Lambda function which will do that data quality validation using DQ or any sort of this kind of data quality related framework. So this is our complete flow. Again, I am reiterating the complete flow from scratch. First, from the raw layer, the event will be getting published in an SQS queue. that SQS queue will trigger Lambda. Lambda will route that event to team specific SQS queue, and we'll be having another Lambda for each team that will basically continuously poll the team specific SQS queue. If it gets the message, immediately it will start a step function. That step function will perform the light transformation. Complete audit or logging will be captured using this Amazon DynamoDB, and after processing, it will write that data in staging layer. From staging layer, the event will be sent to SQS queue, that the new file is written in staging layer, and we are having another Lambda that is getting triggered every 5 minutes based on this CloudWatch rule. And if Lambda find any message in this SQS, it triggered the heavy transformation using AWS. So this way, initially we are having raw data, then in the middle we are getting staging data, and finally here we are getting process data, which is ready for analytics workflows. Okay, so this is our serverless data lake framework, which is basically open source. The complete project link anyway I'll be providing in the description box, the GitHub code base, you can go through that. And now I would like to draw your attention on a major difference between this stage A and stage B, and that is stage A is kind of near real time, because here if you see that as soon as file is getting landed in S3 from this particular generic SQS via Lambda, the event is going to team specific SQS, and as soon as message is available in near real time, Lambda is consuming that and triggering this particular step function to apply light transformation in it. Okay, it is not doing much of batching, etc. Right? Because these are very light transformation what we are applying in this step function, we can apply this particular process on individual small files also. But if you consider our stage B, that is this particular place, here we are using AWS Glue for transformation. Okay, and although Glue is serverless, but mostly it should be used for a good volume of data processing. It is not like for a single file triggering AWS Glue, right? So here, instead of near real time, we should do batching in this stage B. Okay, and how we are implementing that? That is implemented using this particular CloudWatch rule. If you observe, in this particular staging layer, when file is getting landed, here the event is published to SQS queue, and Lambda is not polling this SQS to trigger this step function, but rather this CloudWatch rule is triggering Lambda, and Lambda is checking whether in SQS any message is available or not. Okay, that means that 5 minutes window here, it is basically waiting for accumulating all the files, whatever is getting landed in this particular staging location, and Lambda is triggering this particular step function to process all those files together. Okay, so this particular part, if you see here, it is clearly written batch. Just erase this part. And here is a very vital point, that this particular stage B is for batch processing, and this particular stage A is almost a near real-time system. Okay, and another part of this architecture is CI/CD component, right? So here data engineers need to write the code for the light transformation, as well as data engineers need to write the code for applying business logic in AWS Glue. So this kind of project specific code, how to push? So for that time, we are going to use the CI/CD pipeline using code commit and code pipeline in stage B, as well as if you observe here in stage A. And mostly we need to work with where we are applying transformation. Like for example, here it is clearly directing that the upper part where Lambda is configuring in DynamoDB that this event processing is started, that is also generic. And this last Lambda which is updating in DynamoDB that the event is processed, that is also generic. In the middle, where using Lambda, we are applying light transformation. That part may vary project to project, right? So here if you see code commit and code pipeline only changing this particular Lambda. So instead of using these kind of CI/CD tools, you can use GitHub Action also. But our main focus should be only changing that part which is variable for project to project. Like in this particular stage A, this part is variable. Similarly for stage B, this glue job part is variable. So here if you see code commit to code pipeline, and here it is going to this particular Lambda, which will trigger different glue for different teams, right? So only implement CI/CD pipeline for those variable places, not for whole pipeline. That's what I'm trying to say. Okay, so these are two very important points. One is CI/CD pipeline, one is the nature of stage A and stage B. Stage A is near real time, but stage B is batch processing, right? I hope you understood this. And now, if you think that I want to implement this whole flow in my own AWS services from scratch, that time you can refer some of my videos which will surely help you to implement this complete flow. Let me explain you. So here if you see the initial part, let me just highlight with different color. So if you consider this particular part here, from S3 to SQS to Lambda, this particular flow I have already uploaded in this video. That is, create event-based projects using S3, Lambda and SQS. That same pattern exactly is covered in this video. The link I'll be providing in the description box. Then here you can see this Lambda is publishing that event in SQS, and from SQS this Lambda is getting triggered. So here we should know how to publish a message using Python code to an SQS queue, right? So that part also I have covered in this video, sending message in SQS queue from Python code 3. Okay. Now the next step here, if you observe, this Lambda is triggering our AWS step function. So we should know how to trigger AWS step function from Lambda. So that particular thing I have already covered in this video, and exactly same format, that messages are coming to SQS from their Lambda, and from there it is going to AWS step. Okay, you can check this video to understand the complete flow of this particular part. Okay, right? And then step function, on this I have already covered many videos in my AWS step function playlist. And now here if you see, from S3 the message is going to SQS. Anyway, it is very simple. And here we are having a CloudWatch rule which is triggering Lambda every 5 minutes. Okay, so that particular concept also I have covered. If you see here, this particular video is there, how to configure a CloudWatch event rule that calls AWS Lambda function periodically. This particular video you can refer. And here if you observe this particular Lambda, what it is doing, it is triggering our glue job using step function. So here either you can use Lambda function within our step function to trigger glue job, or AWS step function directly have interaction support with AWS glue, that also you can use, which I covered in this video. Build ETL pipeline using AWS glue and step function, where I have covered in detail how to start a crawler, how to wait for the crawler to be complete state, and then here how to start a glue job and how to wait for it to be completed. So this particular video will give you the idea on interaction between step function and AWS glue. And lastly, here if you observe, everywhere for audit or logging purpose we are using DynamoDB in the stage B also and in the stage A also. That Lambda is writing the data in DynamoDB. So how to insert the data in DynamoDB from Lambda, that also I have covered in this video. So you can check this video for that particular implementation. So like this way, all these reference videos can surely help you to implement this particular SDLF or Serverless Data Lake framework. I hope you understood this. This is all for this video. If you find this particular video interesting, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.